Hey everyone, and welcome to this explainer. I am absolutely thrilled you're joining us today because we're looking at something that has fundamentally shifted the technological ground right beneath our feet. We're going to map out the incredible, literally shocking acceleration of artificial intelligence over just the last couple of years. And specifically, we're looking at how AI conquered an arena that so many experts thought was decades away from being solved: mathematics. Now, this isn't just about our calculators getting a little smarter. No, this is about the mathematical leap that is paving the direct path to artificial general intelligence, or AGI. The acceleration we're about to dive into is staggering, so let's get right to it.
Okay, let's really dive into this contrast because it's wild. If you cast your mind back to early 2023, the initial versions of conversational AI were completely stumped by just everyday tasks. Seriously, if you went camping with two friends and tried to get the AI to split a ledger of maybe 17 different expenses evenly, it would fail. If you asked it to find a common time for a Zoom meeting between Paris, California, and Korea, it simply couldn't do it. Fast forward to the summer of 2025, and these exact same models are achieving gold medal performance at the International Math Olympiad. They literally went from being unable to split a dinner tab to solving elite, high school-level competition math on par with the absolute brightest young minds on the planet. The jump is nothing short of miraculous.
Section 1. Solving decades-old open problems. Moving beyond the benchmarks into novel discovery. Now, competition math is incredibly impressive, for sure, but it kind of has a ceiling. Olympiad problems are basically canned problems, right? They have known solutions, and they're designed to be solved in a few hours. The true frontier of AI isn't just passing human tests, it's pushing into the total unknown. We are going to look at how AI actually started doing research-level mathematics. Take the number 42. 42 years. That is exactly how long a specific highly complex open problem in optimization theory sat entirely unsolved by the world's best mathematical minds. People just didn't know if a famous algorithm called the Nesterov's accelerated gradient method could, in the worst-case scenario, diverge. Well, enter mathematician Ernest Ryu. Over a single weekend, spending just about 12 hours of his evening free time interacting with ChatGPT, he acted as a verifier to the AI's generation. He guided it, corrected its minor mistakes, and pointed it toward novel approaches. And within days, that 42-year-old open mystery was completely cracked. From there, researchers turned the AI loose on the legendary unsolved problems of Paul Erdos, who was one of the most prolific mathematicians in history. At first, the AI began solving these problems through what researchers called a deep literature search result. So it wasn't inventing something from scratch just yet. Instead, it was scanning through thousands upon thousands of complex papers across totally unrelated fields of mathematics. It essentially possessed the sheer processing power to connect the dots between different mathematical languages that no single human researcher could possibly hold in their head all at once. It's like solving a giant puzzle where the pieces are scattered across the globe. But what is truly staggering about the slide and this whole acceleration is the sheer velocity of progress. Initially, researchers were amazed that the AI used that deep literature search to solve 10 of Erdos's open problems. But the real punchline is what happened just mere months later. The AI moved from finding hidden existing answers to generating more than 10 completely new, entirely original solutions. We are talking about novel sparks of discovery that were not hiding in any previous literature anywhere. And they were at a level high enough to be published in the world's top combinatorics journals. The timeline from merely searching to actually inventing was compressed into the blink of an eye. Section 2. Why Math Matters for AGI, the ultimate training gym for general intelligence. At this point, you might be thinking, well, this is great for mathematicians, but what about the rest of us? And that's totally fair. We need to pivot to the core realization driving this entire industry. This isn't just about making a fancy calculator. Mathematics is actively being used as the perfect benchmark to build artificial general intelligence. So the absolute crucial question we have to ask is, why train AI on math? Out of all the subjects in the world, history, biology, creative writing, why have researchers specifically used mathematics as the ultimate testing ground to evaluate AI's progress over the last 4 years? The answer really comes down to clarity and verification. First off, math questions are clear and non-ambiguous. Everyone agrees on what is being asked. Second, the answers are objectively verifiable. A proof is either right or it's wrong. There's no middle ground. But the most important points are the last two. Math requires consistent, incredibly long chains of thought. And in mathematics, a single failure point, just one tiny mistake in a 50-page proof, destroys the entire argument. The whole house of cards falls down. This unforgiving environment essentially forces the AI to develop reliable, self-correcting reasoning skills. It absolutely cannot bluff its way through a proof. This logical training mirrors exactly why we teach mathematics to human students, doesn't it? It's about building the fundamental architecture of clear, logical thought.
Section 3. Enter the automated researcher, scaling the endurance of artificial thought. As these models master these long chains of mathematical thought, their capabilities are fundamentally changing. We're currently witnessing the evolution of AI from acting as a highly capable student to becoming a fully autonomous researcher. Let's look at exactly what that means. Today, we largely operate on the professor-student model. You, the human, act as the professor. You open a chat window, give the AI student a prompt, and it works within a short context window, roughly the equivalent of, say, 50 pages of text. You have to frequently check its work and steer it. But the impending future, that's the automated researcher. This is an AI agent capable of autonomous work over massive data repositories. Instead of a quick chat, you give it a deeply complex problem in math, biology, or coding, and it works tirelessly in the background for days or weeks without needing constant supervision to maintain its train of thought. It's a total game changer. And this brilliantly illustrates the concept of AGI time, which is basically how long an AI can mimic human thinking without breaking its logical chain. Just 4 years ago, the AI could sustain thought for seconds, maybe solving basic high school problems. Then it expanded to minutes for basic reasoning, then hours for early research assistance. Right now, we are sitting at the capacity for the AI to maintain continuous logical thought for days, up to about a week. The ultimate goal, which is rapidly approaching by the way, is to scale the endurance of artificial thought into weeks and months. This exponential expansion is exactly how we reach systems capable of handling the most complex scientific breakthroughs in human history. Section 4. The future human role. Why your expertise is about to become more powerful. So, with an automated researcher thinking flawlessly for months on end, it's completely natural to ask, are human scientists going to be replaced? The answer from the people building these models is a resounding no. Far from replacing us, this tool actually supercharges us. AI will create hyper-interconnected research, surfacing vital connections between niche fields that humans would just never naturally read. It's going to take on the grueling, painful task of verifying 300-page proofs, giving us certainty in days instead of years. It completely removes the manual pain of computation. But here is the absolutely crucial takeaway. The AI does not care. It doesn't care about the beauty of the universe, and it doesn't care about curing human diseases because, well, it doesn't get sick. Humans are the ultimate directors. We are entirely essential for pointing this massive cognitive engine toward the problems that actually matter to humanity. And this brings us to a really stark warning, brilliantly captured in this quote from AI researcher Sebastian Bubeck. He points out that expertise is even more valuable than it ever was. If it wasn't for that, we would not be able to push the state of the art. There is a real danger here of mental atrophy. If we just hand over the keys to the castle and blindly trust the AI without doing the hard work to hone our own skills, we are going to end up trusting fatally incorrect outputs. It takes a master of the craft to know when the AI has made a subtle mistake. We need human scientists to be sharper and deeper in their expertise than ever before to guide this technology safely and effectively. We are standing at the threshold of the most exciting era in scientific history. Mathematical progress really is the canary in the coal mine for everything else, from biology to material science. As AI scales its endurance and compresses what used to be decades of grueling human discovery into mere days, the limitations are no longer in the tools. The question I want to leave you with today is this. As AI compresses decades of discovery into days, how will you use this ultimate tool to push the boundaries of your own understanding? Thank you so much for diving into this explainer with me, and I challenge you to go out and start testing the limits of these tools yourself.